Guys, question is determine the derivative from first principle. First principle. Okay, I want you to notice something. This is not this. So this one here is the gradient, and this one is inverse. The inverse of is the inverse. Okay, so but the question wants the gradient from first principle. So how are you going to do that? I want you to know something. Whenever the question asks you for the gradient, which is the derivative from first principle, you're going to look for f of x plus h. Okay, so because the formula, remember, you use this formula, which is f of x plus h minus f of x over h. This is the formula that you're going to use to look for the gradient. Okay, so you need f of x plus h, you need this. So we have f of x, so wherever we see x, we have to put x plus h, I'm sorry. So this is how it's going to be. F of x plus h is equals to 2 minus 3 into x plus h all squared. Okay, this is how it looks. So now I'm going to take this and put it into my formula here. Okay, this I'm going to put it here. Remember, this is f of x plus h, and this is f of x plus h. This is how it looks like. Okay, so now let's transpose it. This is going to be 2 minus 3 into x plus h. We will simplify this later when we continue. Minus, hey, f of x. What is f of x here? Here is f of x. It is 2 minus 3 x squared. Okay, so don't forget the negative sign here. You see we have a negative sign, so we have to apply the negative sign here. It's no longer going to be 2 here, it's going to be negative 2. It's no longer going to be negative here, it's going to be positive 3x squared. So we're going to write negative 2 plus 3x squared. Okay, and then we will say all over h. Okay, now remember that you are looking for the gradient, and don't forget that is equals to limit h is approaching 0. Okay, so you need to write this limit h is approaching 0. Remember, you will substitute this 0 here at this h. Okay, so now let's move on to the next step. The next step, you will have to start with limit h is approaching 0, and then you will say okay, let's simplify here. You will say 2 minus 3, we can still write 3, and then we can simplify this x plus h all squared. So what's the answer going to be? It's going to be x squared plus 2xh plus h squared. Okay, you still put it in a bracket, right? This is grade 9 maths. Okay, and then subtract your 2, add 3x squared, and then divide by h. Now we will simplify further. Let's simplify further. Remember, each and every step you have to write limit h is approaching 0. Okay, let's simplify further now. 2 minus 3x squared minus 6xh minus 3h squared minus 2 plus 3x squared all over h. Okay, now let's still continue. Limit h is approaching 0. Now here I want you to look at the like terms. Okay, the like terms. Okay, now you have to see that this is positive 2, this is negative, so this will cancel this, This is negative 3x, we cancel positive 3x. So what are you left with? You are left with this portion here. You are left with this portion here. Okay, so now let's write it down. Negative 6xh minus 3h squared over h. Now what's next is you're going to take out h as a common factor. The reason is because h, this is h here, you divide it by h, and don't forget that h is 0. So the reason why you have to take out h, so that the h can cancel this h, because if you just transpose 0 here, you will get error. As you know, anything divided by 0 is error. It will give you error. So that's why you have to cancel out this h. So you have to take out h as a common factor. You can see there's h. So let's go ahead. H into negative 6x minus 3h all over h. You see, now you can cancel the h. You can cancel this h here with this one. You can cancel them. Okay, but if you didn't take out h as a common factor, you was gonna substitute the 0 here. It was gonna give you error. Now you can freely substitute your 0 now into h. Put 0 right here. Right, this is h right here. Okay, you can just substitute your 0 right there. So your gradient is gonna be negative 6x. Okay, so that's your answer. So this is actually long story, but it is simple. It is so simple.